Good morning, students. So today we are going to study about the applications of graph. Okay. It comes under Unit 4, that is non-linear data structure. The main objectives of today's class are, from this video, you can learn about the real-life applications of graph, and you can know about the applications of breadth first search and the depth first search exclusively. So generally, in computer science, the graphs are used to represent the flow of computation. If how the computation flow taken place, it is represented with the help of the graph. The other real-life application of graph is Google Map. Okay. So it uses the graph for building transportation system. So here, the intersection of two roads are considered to be a vertex. Okay, the intersection of two roads, that is this one. The intersection of two roads is considered to be a vertex. And the road connecting two vertices is considered to be an edge. Okay, that is this one. The road connecting two vertices is considered to be an edge. So you can easily navigate through this transportation system. Okay, here we have so many algorithms. So all these algorithms based on shortest path between the two vertices. The next real life example is Facebook. So here the users are considered to be the vertices, and if the users are friends, then we have a connecting edge between them. How the Facebook's friend suggestion algorithm works means it's fully based on graph theory. So Facebook is an example of undirected graph. Okay. So that is like this. So they are the users, and if they are friends, we have a connecting edge between them. So if you want to know about friend of someone, then you can use the graph theory algorithm to solve the problem. Okay. So next we go with World Wide Web. So in World Wide Web, web pages are considered to be the vertices. Okay. So if we move from one page to another page, or if we have the navigation from one page to another page, then we have an edge. Okay. For example, if you are moving from the page U to V, then we have an edge between U to V. So World Wide Web is an example for directed graph. Okay. So it was the basic idea behind Google page ranking algorithm. One more application of graph is operating system. So in graph, in operating system, so in the topic deadlock detection and deadlock avoidance, okay, so we have the resource allocation graph. So using this resource allocation graph, you can easily find out whether there is a chance for deadlock or not. So here, each process and resources are considered to be the vertices. Each process and the resources are considered to be the vertices. The edges are drawn between the resources and the processes. For example, we have an edge from R1 to P1, which indicates that resource 1 is allocated to process P1. If we have an edge from process to resource, that is P1 to R2, it indicates that P1 requests the resource R2 for computation, like that. Okay. So if the edges leads to any formation of a cycle, then there is a chance for deadlock. So in operating system, to finding about the deadlock, we are using resource allocation graph. So it is based on the graph concepts. We move on to the applications of breadth first traversal. So some of the applications of breadth-first traversal are peer-to-peer network, crawlers in search engine, social networking website, GPS navigation system, broadcasting in network, garbage collection, and so on. So hope you remember what is BFS and DFS. Okay. They are two popularly known graph traversing algorithm. So using the breadth-first traversal algorithm, okay, so you can easily search the particular things, particular concepts in crawlers. And using the breadth first search, you can find the find the people within a given distance k from a person k in a social network like Facebook. In GPS navigation system, breadth first search is used to find all the neighboring location. So in the networks, if you want to broadcast some packet, you can go with the breadth first search to reach all the nodes. For garbage collection also, we can use a breadth first traversal algorithm. Okay. So these are the specific applications of breadth first traversal. So we move on to the applications of depth first search. So using the depth first traversal, you can find out the minimum spanning tree and the all pair shortest path. Okay. So if you want to detect cycle in a graph, then you can use a depth first search traversal. So DFS is used for applications of depth first search is used to find out a minimum spanning tree and the all pair shortest path tree. So if you want to find if you want to find cycle in a graph, then you can go with DFS searching algorithm, that is depth first search algorithm. In order to find out the path, you can go with DFS. Okay, that is you can call the function DFS from the starting vertex and you can use the stack concept to find out the path. Okay. And to solve the topological sorting and to test whether the graph is a biparate or not and to find the strongly connected components, you can use the depth first search traversal algorithm. So that's about the applications of graph data structure. Okay. So some of the major applications are in CSE, that is in computer science. It is used to represent the flow of computation. It is used in Google Map. It is used in Facebook, and the same concept is used in World Wide Web and for operating system deadlock detection. And some of the applications of breadth first traversal are peer-to-peer network like BitTorrent. Okay, we can use the BFS to find all the neighboring nodes. Crawlers in search engine, that is crawlers build the index using the breadth first search. Okay, so the main idea is to start from the source page and with the help of the links you can navigate from source to any particular page. Okay. Then social networking websites, navigation system, broadcasting network, garbage collection. So they are all some examples of breadth first search traversal algorithm. Similarly, for depth first search also we have some applications. Okay, that is finding minimum spanning tree, finding all pair shortest path tree, detecting a cycle in a graph, path finding, topological sorting, okay, biparate graph detection, and finding strongly connected components and so on. Okay, with this we are concluding today's class. Okay, thank you.